Good day everyone, and I am Joshua V. Atok. So for today's video, I will be presenting to you on how to use this Excel program for the design of actually loaded for both tide and spiral column using 2010 or 2015 specification. First, I will be presenting to you the tide column reinforcement, and for me to elaborate on how to use this Excel program, we are going to design a column from the situation given here. So in this situation, design a square tide column to support an actual dead load of 1890 kN and an actual live load of 2300 kN with the use of FC prime of 21 MPa and Fy of 276 MPa. So here in our input values or parameters, we are going to put the given values. First is the dead loads and live loads, which consist of 1890 for the dead load and 2300 for our live load. And with this loading, we are given with a value of 5948 for our actual ultimate load or the actual loading of our column. So next, we are going to input value for our FC prime and Fy, which are 21 MPa and 276 MPa from the situation given. Next is we are going to input or assume a value of stale ratio that ranges from 0.015 to 0.030, which are the ideal values. So let's assume 0.02, and with that we are given with an area gross of 497,043.477. This value is the total area of our cross section of the column, in which it has a cross-section or dimension of 705 by 705 cubic meter squared rather. And furthermore, after getting the value for the cross-section of our column, we are going to get the value for our reinforcement. And for the main bar, since there are no given, we are going to assume value of, let's say, 32 mm with a 32 millimeter diameter bar. We are given with a number of bars required of 13, and since the 32 is less than or equal with a value of 32, we are given with a lateral ties of 10. And from that, for our vertical bars reinforcement, we got a 13 number of bars of 32 millimeter diameter of bars. And for the spacing, we are going to get the lesser value from these three. Since 480 is the minimum value among the three, we are going to use a spacing of 480 mm with a 10 millimeter diameter of lateral ties. Furthermore, for the capacity check of our design column, we got a stale ratio with lesser of 0.01 with the remarks of okay means acceptable, and for the ultimate load of 5948, which is equal to the value given here, which is also okay. For me to elaborate further, this main bar's value of diameter can assume a value higher than 32, which is 36. And notice that the value for our lateral ties change at 12 millimeter. And for our spacing, it seems like the S for these both is similar. Hence, value for our spacing at 12 millimeter diameter lateral ties is 576 mm. And for the capacity check also, it seems like it is acceptable, so the design is okay. So in continuation with this tutorial video, now we are going to proceed in the design of spiral column reinforcement with a 2010 or 2015 specification of NSCP code. And for me to elaborate again on how to use this Excel program, we are going to design a round spiral column with this situation. And the situation states that the spiral column is supported with an axial dead load of 1,800 kN and an axial live load of 2,330 kN with the use of FC prime of 21 MPa and an FY of 415 MPa for vertical bars and FY of 276 MPa for spiral. And here, from the given situation, we got parameters for our loading of 1,800 for our dead load and 2,330 for our live load. With this loading, we got a value for our ultimate axial load of 5888 kN. And for our FC prime, we got 21 MPa and 415 MPa for our FY of vertical bars and a value of 276 for our spiral. And in order for us to get the value for our area gross, we are going to assume again a value for our steel ratio that ranges from ideal values of 0.015 to 0.03, and I will choose 0.02. And with that, we are given with this area gross of 358,084.691. And remember that we are going to design a round or circular shape column. And from the resulted value for our area gross, we are given with a diameter of 675 for our cross section of our column. And now we are going to proceed with the number or with the main bars or the reinforced bars for our column. And let's assume a value of a diameter of our main bars, and I will assume a value of 32, in which we are given with a number of bars of 9. Therefore, our vertical bars consist of 9 of 32 millimeter or 9 number of bars of 32 millimeter diameter. Since our value for our main bars is 32, let's use a 10 millimeter diameter for our spiral. And by the way, spiral must have the minimum value of a diameter of 10. And since we get value of 10, so it's safe lang man sab. So from this diameter given, we are going to input a value for our cover or the offset of our reinforced spiral from the outmost circumference of our column. So I'll assume a value of 42 millimeter of the cover. And from that, we are given with a value for our AS or the area for our steel or spiral, and the diameter of our core 595, and the area for our core, the area gross rather, and the row minimum, which is prerequisite in solving for our spacing for our spiral. Since S is given as 52, this is not yet our final spacing for our spiral. We are going to deduct it with the value of the radius on the above and below of our spiral diameter. Since our spiral is 10, the radius is 5. Since we are going to consider the above part and the below part of our spiral, hence it is equal to 10. And we are given with a spiral of 10 millimeters in diameter with a spacing of 42 millimeter. And for the check capacity, it is visible that our rho G, or the still ratio gross, is greater than the value of 0.01. And for our ultimate actual load of 7492 is greater than the 588 for the actual. Hence, the design spiral column reinforcement is acceptable. And that's all for this tutorial video. Good day and thank you for watching.